welcome to IVI's webinar series on digital construction. Today we'll have a specific focus on integration of IoT data and BIM for energy management in buildings. This session is being recorded for on-demand access, so we would also then please ask you to take the opportunity to ask questions or indeed share your comments and in the Q&A section. So I'm just going to move the screen on so you see the agenda there. So we have an excellent lineup of speakers. So we'll see the Q&A session is at the end. But again, please feel free to put up your comments as we go, and we will address them and put the questions to the panel at the Q&A session. So this is, of course, a really topical area with energy consumption management, energy management being high on the priority list for all organizations. There's so much data being generated from IoT devices and buildings, some of it valuable, some of it not. And I guess therein lies a problem that some of that data isn't valuable. So it's getting to the right data, and the availability of that valuable data has the potential to transform building construction, administration, management and maintenance. So for today's webinar, we'll look at the challenges in facilities and energy management in relation to IoT integration with other digital tools or data sources available in construction and the building industry. We'll also discuss how to advance that IoT technology implementation in digital construction. So I suppose we'll just move on now to the introductions, and I'll start off with my own introduction. My name is Denise Manton. I'm the Executive Director of Empower, which is a €10 million multi-stakeholder research programme dedicated to the broad and multi-disciplinary field of data governance. It's co-funded by Science Foundation Ireland and industry partners. The programme brings together 4 world-leading research centres: Lero, Adapt, Insight, Future Neuro, and I think have I them all there? Yes. So we today, I suppose, we are going to look at data, and that from my perspective, I definitely have a specific interest in that. My own background spans academic and research environments, and also in control systems engineering and greenfield sites and through to commissioning. So I'm really looking forward to the speakers today and what they have to say. So enough of me talking. Let's move on to the really good stuff. First up in the spotlight, we have James Lawson. So James is a research engineer at Murphy Geospatial. He is a Trinity College graduate with a degree in civil, structural and environmental engineering, specialising in renewables and structural engineering. He wrote his master's thesis on the value of building information modelling for the creation of a digital twin. In his current role as a research engineer with Murphy Geospatial, he helps produce research reports as part of the Research, Development and Innovation Hub at Murphy Geospatial. So James, I'm going to stop sharing my screen and I'm going to hand over to you for your talk.
Great, thanks very much, Denise, for the introduction. I'll just share my screen here. So yeah, hi everyone. Thank you very much for joining us today, and thank you very much for IVI for allowing us to present. So Murphy Geospatial have worked closely with Maynooth and IVI in the past on projects such as this one, particularly around the benefits of IoT in construction, and we'll certainly look to do so more in the future. So under the overall theme of digital construction, my presentation is on the value of geospatial management, particularly in the architectural, engineering and construction or AEC sector. So Denise already gave me a bit of an introduction, but I studied civil engineering in college, and my master's thesis focused on the value of building information modelling to different stakeholders on a building project in Dublin city centre. And this research project is something quite similar. So today I'll talk a bit about the process of what geospatial management is, the business case for it, and some of the potential savings that can be made on the construction side from the results of research conducted in-house by the RDI, or Research, Development and Innovation Hub. And finally, I'll open the floor to any questions that you have. So this presentation is the result of a 2-year project conducted in-house that looked to deliver data-driven intelligence and reports on improvements in cost efficiency due to geospatial management services, identify and report on cost indications of different construction methodologies relating to geospatial management, and finally identify where GM or geospatial actions have resulted in a measurable improvement in cost efficiency. So the project was conducted by myself and Paul Quirk at Murphy Geospatial, and resulted in the production of 2 white papers, one on the value of geospatial management in the
Sorry,
AC
James.
sector.
Sorry, James, I'm just going to cut in for a second there. Apologies. We can't actually see a few slides there as well.
Sorry?
Had you some slides there? We just can't see the presentation.
Oh, right. I'm not sharing my screen.
Okay.
Yes.
There you go. Perfect. Perfect.
Right. So yeah, for a second. That's all coming through there?
That's perfect, James. Yep.
Grand, yeah. So yeah, I'll set the stage with what I think is quite a non-controversial statement, so that not everything on the construction side goes to plan. And I think even those new to the industry know that not every construction project goes off without a hitch. So this can be due to clashes, rework, or general delay of works. Sorry, having a few technical issues here. Sorry about this.
It's okay, James. It's always when everyone's watching, isn't it? These things.
That's it, exactly. Yeah.
Then.
I'll just close everything now and try to reopen it again. Not even 5 practice sessions, I still get something wrong. Okay. All right, let's try this one more time. So back in 2020, Autodesk released an eye-opening figure that identified data in the construction industry is going to waste. Now, a lot of data is going to waste all the time. Everyone has clutter on their desktops, to name one example. But when that impacts decision-making and leads to an increasing amount of poor decision-making, it can harm the industry. So in 2016, a study conducted by academics in UCL in the UK, the Get It Right initiative, gathered a group of experts in the UK for several rounds of interviews, and using something known as the Delphi method of qualitative analysis, found that up to 21% of overall project costs go towards some sort of error than what was the work that was intended to be done. So you can see different types of error and the relative weight on the project costs here, and we'll go into a bit more detail about what each of these means. So both physical and digital assets are not being utilized fully in the construction industry. But to a lot of people in the industry, this isn't necessarily new information. So with the advent of new technologies and ways of working, such as modern methods of construction, the role of the construction surveyor is forever evolving. So when considering the impacts of error in the industry, the surveyor or geospatial manager is positioned to maximize the benefits of construction data through coordination, control, and stakeholder engagement. So what is a geospatial manager? So Murphy's a framed function of a GM in terms of collaboration, coordination, control, as I said. On the construction site, baseline coordinate networks, fundamental site drawings, BIM models, etc., to keep everyone on the same page. But when you bring 3D scanning data into the mix and progressively update a building's progress tracking as it's being built, the correct management of that data is a necessity and can involve having a gatekeeper to govern that data. And at Murphy's, this is brought about on several projects through what is called a geospatial management plan. So the process is based on fundamental concepts, as I've said before, collaboration, coordination, and control. And this means engaging with different stakeholders to change the culture and mindset around the quality of installations. So taking you through the diagram on the right hand side here, you can see the process flow verification. So once the client approves an area to be verified, surveyors are sent out to generate a verification report. This is validated by the geospatial manager, and all things going well, the building information model is updated to reflect site conditions. So a bit of a more visual demonstration here, taking a simple steel column as an example, you have one designed and one is built or installed on site. That is when the geospatial manager comes in and takes a 3D laser scan of site conditions and compares that with the original design to show the true location of the elements. So this empowers design teams and contractors to make better informed decisions for future builds. Another example here, take a simple pipe installation, say that this is out of tolerance from the design by maybe a few centimeters in this case. So depending on what the tolerance is, what's set by the client and the geospatial consultant for the region this particular element lies in, the element might have to be redesigned or removed. But the great thing about more minor elements and errors such as pipes and steel columns is that we can get ahead of problems like those and make changes easily and cheaply. But what if, for example, concrete pour or oil is misallocated by, say, 100 mil? Critical components like these can alter an entire build. So you can see that as errors such as these get bigger on more critical elements and risk gets a little bit more out of control, having an individual responsible for providing certainty from a project inception and to take on those kind of potential liabilities for those kind of mistakes could be essential. So structurally, in an organizational sense, this is where the GM sits on the project, serving as an independent advisory role to what is sometimes called digital integrator or client representative. So this has been an introduction as what the geospatial manager does and some insight into the process. And now I'll go on to our findings from the research project and business case. So I'll give everyone a second to digest that before we go into what was a 2-year research project where we looked at globally available literature, research papers, government and corporate documentation, as well as doing some expert interviews across the industry to find out how much this process could actually save the industry in time and cost. So moving on to the research, we heavily leaned on empirical findings, so findings found directly from construction people and projects from 2 existing studies, one of which is a risk mitigation consultancy, HKA. They developed an insight report that has reviewed over 1,600 projects across 94 countries over the past 24 years. And their goal was to uncover the scale of the impact that claims and disputes have across every world region. So their yearly report, Crux Insight, has an accompanying dashboard that shows the causes, claims, and disputes of construction projects around the world. So currently just over 1,600 projects. So I would say that this data is actually valuable for calculating the value of any novel method, modern method of construction, geospatial management being just one example. And then the Get It Right initiative, or GERI in the UK, is a collection of construction industry experts with collective objective to effectively nullify on error on the construction site, and they gathered a steering group and held discussions on the most common causes of error. So using data gathered in 2 comprehensive industry reports, we applied our own findings and assumptions and gleaned that geospatial management has the potential to reduce 5% of on-site error and 5% of extended time. So these may be relatively small figures, but when you consider the economics of scale on large construction projects, these savings can be actually quite significant. So once again, showing this 21% of cost of construction going towards error. So due to the nature of different types of error, we assume that geospatial management can mitigate indirect costs that come as a knock-on effect of direct errors. A foundation being out of place leading to a full building redesign is just one example. And also latent defects, which are errors found after the fact, after an installation. So moving on to projects conducted by Micro Geospatial. Here are 2 examples of the case studies, one being the construction of a manufacturing facility and the other a pharmaceutical plant. Recording the accuracy of installs over the course of the project or using what we call geospatial analytics, we found that site installation accuracy improved by about 21% cumulatively over the course of about 2 years. So this was done through the reports and monitoring, etc., but also through changing how project parties thought about error on site and site culture. So in the figure on the bottom left-hand side, the arrow shows how installation accuracy builds over time as more trades were on board onto the process. And on the pharma plant project, the identification of errors on site resulted in several identified instances of cost savings. So focusing on individual errors, Cost team found that having geospatial management in place saved on preventive rework and delays in instances ranging from a couple of €1,000 to nearly $750,000 from the indirect impacts that were avoided. So slight delays, costs to the general contractor, and material costs were all considered in this figure, but what wasn't considered was delays to the production cycle for the client or any reputational damages that might have resulted. So even though there was $750,000 saved, it could have actually been a lot higher. So these are the headline figures from what has been established in the research. So from the jury analysis, we found a potential on-site error reduction of 5%. This is cutting down on those indirect costs and latent defects. From the Global Risk Management Consultancy study, a potential 5% reduction in percentage of time due to less claims and dispute. So less time worrying about who is liable for what and more focus on the work. Then from our empirical case study, up to a 21 installation accuracy improvement was attained and measured using geospatial analytics to track the project. And in total, from our analysis and the assumptions made based on expert opinion, we found that geospatial management can save between 1% to 2% of overall project costs. So that concludes the bulk of this presentation. For those of you looking for more, this presentation has an accompanying white paper, which will provide you with all the details you need on geospatial management and a comprehensive and transparent review of the analysis.
Thank you, James.
Yeah.
Oh, sorry.
No, that's everything from me. Thanks very much for your time today.
That was excellent. Thanks so much, James. I think it's really interesting to see, I suppose, the process-driven approach as well. That's really strong on that side of it, and being able to put up tangible numbers there and tangible benefits, I think is huge. Really interesting to see the cost mitigation and the avoidance of all these costs that can build up through errors. So very, very interesting, and I'm sure there'll be lots of questions at the end for you, James, on that. Next up, we have Ralph Montague. So Ralph is the director of ArcDocs, a specialist BIM consultancy practice based in Dublin, providing professionally managed advice, product support and training services to the construction and property industry. A registered architect with almost 30 years experience in managing large projects, Ralph endorses BIM as the most cost-effective and highly efficient way of producing and managing design and construction documentation and improving the building process. Ralph is a member of the National BIM Council of Ireland and coordinator of the Construction IT Alliance BIM group. And through this work, has been instrumental in leading the development and adoption of BIM in Ireland since 2009. Ralph has also been the chairman of the Royal Institute of Architects of Ireland and the practice subcommittee for BIM, and has represented Ireland at European level as well. There's a long list, Ralph, of some more associations and the wealth of experience that you have in this area. So without further ado, I'll hand over to you, Ralph, for your presentation.
Thank you, Carol, and thanks, Zora, for the invitation. Yeah, in terms of this conversation, I suppose I wanted to bring us back down to earth. You know, when we talk about data and talk about IoT devices and everything, it's sometimes we forget that we're talking about real stuff like the built environment. And this lovely picture of Dublin, as we look at this, you know, we realize how important the built environment is to every single person. It's where we live, it's where we work, it's where our kids go to school, it's where we care for people, it's where we trade, it's where we play, it's where, you know, it provides the infrastructure for clean drinking water, safe food, energy, communications. Even the fact that we're having this conversation, you know, over the internet is dependent on so much infrastructure, and that's what we're talking about. And the point I wanted to make with this was, as we look at the built environment, nothing that you see in this picture was created without information. Yeah, not a single thing. Like the people had to create information in order for this built environment to come into being. And in order to continuously maintain and operate this built environment, we need information. And now a lot of the information to date has been analog, and it's difficult to process and use, and maybe not available. But that's where sort of digital data, IoT devices, everything comes into play as we digitize this physical infrastructure in the form of a digital twin. It provides us with a rich amount of data. But that's my first point, that we've got to begin to see everything as information and information as everything, because that is a reality of our built environment. And even the biologists among you might know that everything we consider as matter is actually codified information. It's atoms coming together to form molecules and structures, etc. So even the definition of the word information, I love this word because it describes something that's in the process of becoming. You know, it's something that's in formation. It's being resolved, and it's the instructions that describe what has to happen. But in terms of data, and you mentioned it at the beginning, Denise, like the quality of data is incredibly important, as it informs our actions and our decisions. And related to that is an issue of ethics, professional ethics, which I'll touch on. But in terms of quality of data, obviously there's a spectrum from bad data, or even corrupt data, you might say, which can be described as sort of incomplete or unresolved or withheld. I mean, and then good data. And of course, to achieve excellent data is an expensive process. I mean, it takes a lot of time, it takes a lot of effort to achieve complete data. But on the other hand, when it comes to executing any work in the physical environment, and by that I mean designing something or constructing something, or even maintaining and operating something, the quality of data will impact on that. And if you have good quality data, it's the cheapest way of designing and operating infrastructure. And as the data quality decreases, so your costs increase. So that's always important to remember as you're trying to shortchange people in the design phase who are creating this data in the first place, trying to save a few bucks by getting them to produce less quality data. You'll pay for it later, I suppose, is the point. And sorry, related to that, I think there's a question of a duty of care of us that operate in this industry as professionals. We have a duty of care not only to our clients, but to society at large, to produce the best quality data that will achieve the best outcomes. And one of the worst things I hear when talking to professionals is, well, my client didn't ask me for good data, so I didn't give it to them. And I mean, I was just imagining going to a doctor and saying to you, well, I didn't give you the best medical treatment because you didn't ask me for it. Or going to a lawyer and saying, well, I didn't give you the best legal advice because you didn't ask me for it. That would be unethical and unprofessional. So there is a question of ethics that as professionals, we must remember to operate to the best of our abilities, not only to meet the needs of our clients, but also to meet the needs of society at large. But as we begin to digitize this physical environment, and embrace this concept of the digital twin, I just wanted to explain at a sort of simple level what that means. Obviously, within the physical environment, buildings and infrastructure are really just collections of components. Buildings and infrastructure are made up of materials and pieces of equipment and components that are brought together. So if I just took the idea of a digital twin of one component, and you could understand that, then you can scale that up to any level, to a building level, to an infrastructure level, to a campus level, to a city level, etc. So on the one hand, you have the physical component or the physical asset. In this instance, I'm just showing an air handling unit, but we need some data now, digital information to represent that. The first type of data is data about the physical dimensions of that piece of equipment in 3 dimensions. In other words, that piece of equipment will occupy space in the world and the world is a 3-dimensional world. So yeah, it's the size and the shape of that thing. It's also its location in space, and that's why I like the connection with the geographic data that James is talking about, and also the relationship that this component has to other components. So the connection details to pipes and other electrical services, etc. So I'm just going to classify that as graphical data that describe the physical presence of an object in space. Then, of course, we need to have other data. We need data about the operations and physical aspects of this, or functional aspects of this component. So that could be who the manufacturer was, what the airflow rate is, what power supply it needs, when it was purchased, when's the warranty expiring, you know, all sorts of useful information that is important to maintain and operate this piece of equipment, and that would include information from sensors and IoT devices that are reporting back on the actual performance of this piece of equipment, you know, over time. And so I'm just going to classify that as non-graphical data or alphanumeric data that computers can process. But I just want to remind ourselves as well that we operate in a very regulated industry, and we are required by various regulations to provide documented proof of compliance with those regulations, such as planning, building control, safety, health and safety, environmental impact, etc. And so not to forget about all the important documentation that needs to be provided and accessed if needed. Called record documentation, if you like. And these 3 types of data that we need about every single component and every single material that makes up our built environment is held in what's called a common data environment. So, and yeah, that the information management standards, these international information management standards that have emerged, describe this environment as the place where all this information will be available. Of course, when people are talking about IoT devices and energy management, you know, they're talking about a very specific subset of the data, but it's still a subset of data that should be available within the common data environment. And then in order to make digital connections between all these types of data, you need to begin to create a common language, a common data language of classifying these components within the world. So classifications are a very important part of the digital puzzle. Of course, in this environment, this is BIM. This is what BIM is. So a lot of people think BIM is just 3D models and it's just graphical data, but actually BIM, as described in the information management standards, is all 3 of these things and how they come together. But when you operate in this way, well, the lovely thing is you can have all your old analog documentation like drawings and schedules free of charge, basically, because there's enough geometry in the objects to represent themselves on drawings. So if you want drawings are very useful things to have, but not if you have to draft them manually. But in a digital world, you can have drawings that are generated from the data itself. You can have schedules. So some people like to work with schedules, and that's perfectly fine, but you don't have to type out the schedule manually. The schedule can be generated from the data itself. And you can begin to use this data for all sorts of things, such as coordination and clash detection, for the sequencing of logistics over time, procurement, cost analysis, energy performance, energy analysis, monitoring of energy. So it's useful to use IoT devices to monitor energy after the fact, but you also want to predict how something's going to operate before you build it. There's no point in building a building and then figuring out afterwards that it doesn't operate the way you wanted it to. It's much cheaper and much better to analyze the proposed design beforehand and make sure that what you're building is going to perform the way you want it to. And then, of course, for people like Richie, who have to maintain and operate all these buildings on campuses, having all this data to hand for operations is incredibly important. So that's the overall picture. The last piece of the puzzle of the digital twin is this IoT connection between the physical and the digital. And I'm saying it's the last piece because a lot of people focus on the IoT devices and all the interesting things that technology can do with data without getting the foundation right. And so, making that connection should really be something that's considered as the last step in the puzzle. If you don't do it that way, then you're back to the traditional way of practice in this industry, which is to produce paper documents. So drawings that are manually drafted, schedules that are manually typed out, everything printed out and put into a box, which goes into a storeroom and is of not much use to anybody. So as you look at this picture, I mean, this is a safety file. There's a regulation that says we have to, at the end of a construction, produce a set of information for clients that represent how the building was designed and constructed. And this is the way it typically gets delivered as lever arch files in boxes that go into storerooms. But that's, despite all the costs of producing that's not very useful to anybody. It's very difficult to use that set of data, and very quickly it becomes out of date and obsolete. So that's not the way I would suggest to go. As we think about this topic, it's not just about data. Like, as you said, Denise, at the beginning, we produce tons of data, but it's not useful. Like, to make data useful, we've got to add something to it. We've got to add some context. And this is where these dimensions of the third dimension, the fourth dimension, the fifth dimension adds context to data to turn it into information. And as we begin to structure the data and organize it, it becomes meaningful, and that's when it becomes knowledge. And once we have knowledge, we can then reflect on it and action it, and that gives us the wisdom to perform. So lots of data is very real, but it's not very useful. Wisdom is very abstract, but it's incredibly useful. So and my last point really was, we don't have to reinvent the wheel. There's standards that have been developed over many years by lots of intelligent people about how to do this. Most of these are international standards. So now the problem about standards is they're mostly voluntary. So unless they're called up in regulations, people don't tend to use them, but they're there for a reason. Standards is one of those things that people hear the word standards and they immediately switch off, and they think it's something that's boring, that it's it's going to add some additional burden or to their work, etc. But actually the opposite is true. Standards are the reason things work. The reason we have clean drinking water, safe food, buildings that don't collapse on us, etc., are because of standards. And so countries that adopt standards and work to high standards are generally more prosperous, and countries that don't adopt standards are generally dysfunctional. So that's really important to remember. These standards are there, we should be using them, and it should be the basis of how we practice. So hopefully that was helpful for the discussion, and we're happy to help talk further. Thank you.
That was great, Ralph. Thanks so much for that. I think we definitely need the reminder at the start as well that around the built environment, that it is everything around us, and that we are so I suppose reliant on everything there, and right through to, as you say, the discussion on information, on data, the good versus the bad. It's all so important, and finishing there, of course, on the standards point again. I suppose sometimes it can be people looking to take shortcuts, leading to disastrous things later on for all involved. And I think that will be something that we'll delve into a little bit further at the end as well. So thank you very much, Ralph. So next up we have Richard Kelly, who is the Estates Manager at Dublin City University and is responsible for energy performance and the strategic development of energy systems and infrastructure across all of the DCU campuses. So quite an undertaking there. He is a chartered engineer and has over 30 years of consultancy, project, operations, facility and energy management experience. Richard holds an honours degree in Building Services Engineering from the University of Ulster and an executive MSc in Business Administration from DCU. And not finished yet, a postgrad diploma in sustainable energy also. Is also a certified energy manager, certified energy auditor, certified measurement and verification professional. And there's a few more to list there as well. So a very impressive list of certifications and qualifications there. So we will hand over to you now, Richard, to give us your presentation.
Yeah, thanks a lot, Denise. Jeez, I think I've been studying too much. Now, can everybody see that screen?
Yep, we can see that perfectly. If you want to go to display mode, just in the full
slideshow.
Perfect.
Great. Okay. So look, this is just really just a very quick presentation on DCU and kind of how we manage energy in DCU and our kind of plans for 2030 and beyond. So I just kind of have a slide for each of the kind of topics I've done there in terms of our progress today, the targets that have been set, the system we use, our strategy, and then maybe what might be most interesting today is just a little bit about energy control, energy data, energy intelligence, and energy modeling. And then I'll just finish off with some kind of plans and the challenges that are set. So I suppose the first thing there is in terms of progress, we're doing very well. We have lots of campuses. We have nearly 90 buildings, 20,000 students, 250,000 square meters of buildings and over 2,000 staff. So we're quite energy intensive. But for the 2020 targets, we've done very well and we're on track to do similar for 2030. Probably most importantly, more than kind of energy, is our decarbonisation strategy. And already we're about 33% towards the 51%. So with about 7 years to go, we've about 20% of our decarbonation still to go. So we're doing pretty good. There's our kind of a slide just on our targets. And again, it just talks about the two main targets for DCU in terms of a 50% energy performance improvement. We're already at 60 and 51% carbon reduction. We're at about 30, so about 20% to go. Interesting there, just in terms of all the data, etc., etc. The larger part of that slide, you can see the green elements are our decarbonisation plans for our existing buildings. But on the other side of things, we're building so much. We've got such a kind of a dynamic building plan over the next number of years. The red signifies the additional carbon that's going to come from our new buildings, even though they're fully electric, non-fossil fuel buildings. So we do have a challenge trying to save energy, but building new buildings at the same time. Ralph mentioned systems and standards. We have ISO 50001, and again, it's a really important kind of part of our strategy to reduce energy in DCU. So that's our strategy. So the kind of pyramid to the left-hand side is kind of what we want to do in terms of to ingrain energy awareness and energy consciousness into the culture of our staff and students. And then on the right-hand side, it's more to do with our kind of energy and our decarbonisation planning per building and per campus. So we've set kind of targets, as I mentioned, and our various enablers to get to there are those items on the right hand side. So from energy management, energy efficiency, demand response, all the way down to kind of future energy solutions. So all of those enablers that we've listed are all the different ways that we're tackling reducing energy and kind of decarbonising our energy systems. Control is really important. Again, it's been mentioned already, the IoT and all of those kind of measurement devices and data is so important for us. Control is just, we couldn't do what we do without having the proper control in place. So We have a building management system. There's a few kind of graphics you can see there. So every system that uses energy in DCU is on our building management system. And then we can control whether it's a boiler, an air handling unit, a chiller, a heat pump, and plus all the ancillaries like pumps and fans and valves. We can control them all from our building management system. And by doing that, then we can interrogate problems, but also drive energy down little by little by little. So I've given a few examples there of different kind of control charts we use and ways to address how we're performing versus our targets. So energy control is really important. Data is super important as well. You cannot manage what you cannot measure is a kind of a famous kind of saying by Peter Drucker. And it's absolutely true when it comes to energy management and energy decarbonization. So we manage energy on 15-minute intervals. So we're doing it 50-minute intervals, hourly, daily, weekly, monthly, and annually. And again, with all of that data, we can set the targets to be more and more ambitious and more aggressive. And again, intelligence is really important as well. We need to know where energy is being used, when it's being used, how it's being used. And that's right down from an air handler or a chiller or a boiler or a heat pump, but also right down to the equipment that could be in a laboratory, you know, like a fridge or a freezer, et cetera, et cetera. So again, we get down to kind of trying to get the most intelligent data that we can get, so that we can kind of manage energy downwards and continue to keep driving it downwards. And modeling is also important. Ralph mentioned it there as well. So if we're building a new building, like for example, our new Polaris building that's on site at the moment, and that's in the kind of left-hand side of the screen there, you can see a snapshot of it. What we do is we model that building while it's being designed, and we want to make sure that it's an A2 design, et cetera, et cetera. But when we appoint a contractor, we also put a responsibility on the contractor to also separately model the project themselves. And then we compare and we make sure that the building that's going to be built by the contractor is going to be achieved versus what the designer modeled and designed. And there's always a difference. We call that a performance gap. So you can see in the bottom left-hand side of that screen, the designer's designed to an A2 BER rating, and you can see that it's probably going to have a 324 megawatt hour per annum energy use. But if you actually look at that building in operation, it's going to be using a lot more because the BER modeling does not include for equipment and a number of other energy using areas. So what we do is make sure that we can identify that performance gap so we know exactly what's coming down the track. And also when we have that performance gap, we can then drive that kind of actual potential energy use down further. And I just gave a few examples there as well, where we're decarbonising kind of our district heating scheme on the St. Patrick's campus. And before we do anything, we make sure that we fully model the building so we can dynamically see how energy is used in that building throughout the year. And then when we compare that with the data that we have in our building management system, we then have a perfect baseline to integrate a heat pump into something like a boiler system there, and then be able to fully understand how much we can drive that down so that we can get a real return on investment. And then kind of nearly there, just in terms of our plans, you know, we have a number of targets. We want to make sure that we have savings of about 14 gigawatt hours renewable heat by 2030. We'll do that through heat pump integrations. Any new builds on DCU since 2020 don't use any fossil fuel. So we're trying to eliminate at least half of our gas consumption by 2030. And then renewable power is the other big one that we want to do. So we want to have about 1.5 megawatts of PV on all of our roofs by 2030. If we do that, we'll easily achieve government targets and we'll be way ahead of them. That graph in the middle as well just kind of shows that in 2022, we have about 30% CO2 reduction. And our target for 2030 is 60%, as you can see there. which will be about 10% more than the government targets. So last slide, just in terms of the challenges, it's all the typical ones that kind of energy managers have. We're still living with COVID, so we can't recirculate air anymore. Everything is full fresh air, which has to be heated, etc. Electrifying our heat is a big challenge. And resourcing and financing is a big one. But I just thought I'd just end with just 3 items. Data. You know, sometimes you can have too much data, sometimes you can have not enough data, but data is so important to manage energy in buildings and campuses. So everything that Ralph and James was saying there is absolutely crucial. And also what Ralph was saying about building information modeling, it's so important. But what we're trying to do in DCU is to make sure that the energy modeling is integrated into that building information modeling right at the very start of a project. So that's what we're doing for all our new major capital buildings. And it's so worthwhile because we know exactly what is being built. So does the contractor, so does the designers, and it makes setting targets then and having low energy buildings, just the way we need them, because the targets are so hard to hit. So that's it from me. Hopefully you just enjoyed those kind of couple of slides. It was kind of like a whirlwind visit to DCU and what we do. Thank you.
Thanks so much, Richard. That was hugely valuable to see, I suppose, the progress that you've already made on those targets, and we'll be looking forward to hearing, maybe having you back in another while and to see how you progress on that. I think your last point there again is also, I suppose, as it ties into what Ralph was saying as well, and what James told me, putting that upfront effort in at the design stage where possible. And I guess it's easier in new builds, maybe a little bit more difficult with existing buildings and that. But that's another valuable point again that we will have to, I think, go a little further into in the discussion stage. So thank you so much for that. And we're going to move on next to Damien Brown. So Damien is the founder and CEO of Standard Access. He's also an innovative PropTech leader, heading a team of skilled deep tech experts, has an extensive background as an owner and manager of a multinational commercial real estate investment company, and through this developed a passion for creating practical real estate technology solutions. As CEO of Standard Access, an international award-winning real estate tech company, Damien focuses on addressing access management and space optimization challenges faced by property managers. Damien holds a US patent for secure remote building access and has achieved significant milestones in this field. His also notable contributions include the development of the first digital spine, which has since been explored as a model by the UK government, and has also designed an AI tool to monitor building energy performance and provide guidance to achieve ESG targets. And if that wasn't enough, Damien is also a co-founder of Blue Power Energy, and that specialises in ocean renewable energy. So Damien, over to you.
Thanks very much, Denise, and thanks, Zora, for having me, for inviting me along. I don't have a presentation for you for today to the audience, but I'm just going to tell you a bit about us and our story, and where we are today and where we came from in our journey in property technology and real estate technology. As Denise mentioned, we have, I suppose, deep domain experience in IoT, access control, and in machine learning and artificial intelligence. We started our journey about 7 or 8 years ago now. Like Denise said, I spent most of my career buying and selling commercial property investments. And during the last recession, I suppose I lost a lot of my tenants in the first 12 months of the recession in 2008. And I was looking for ways to better manage my portfolio, and portfolio was in about 15 locations across 3 countries. And the problems I had were being duplicated in every site. Like key holding was a big problem, and keys ending up in the wrong hands was a big problem. Not being paid rent became a big problem during the recession. And I actually ended up in situations where I had unauthorized people inside in buildings. And I saw for a few years I was trying to figure out a way how to better manage the portfolio, and I came up with what if you want to call it the eureka moment in 2014 or 15. I figured out that I could use a mobile phone to manage access into a building, and also to manage the people who needed to use that building, by them being able to book a space, pay for a space, and get the keys back to their phone. And so I went to my local college in Tralee, the IT, which is now the Munster Technical University, and I went to Enterprise Ireland, and I told them that I had this idea to use mobile phones to manage the selling of renting of space and the corresponding access into the space. So it was monetized time restricted access that I wanted to develop. So the university in Tralee said to me, you know, we can use technologies like Bluetooth or NFC between phones and doors to open doors. And at the time, NFC was only available on the Android phone, so I didn't want to use that technology. And they mentioned Bluetooth, and I didn't want to use that technology because of pairing issues. So I said to the college, I said, listen, I said, do you remember when mobile phones, ringtones came out back in the early 2000s, and you could download a ringtone to your phone? And I said, look, can a phone send a ringtone or a message, a burst of sound, a burst of audio to a door to say, hey, I'm Damien, let me in? And it turns out they could do it, which is great because every phone obviously has a speaker and microphone. So that meant that every person in the world could use the technology that I wanted to build. And so the hardware side of things could be done, but then we wanted to build the software as well to allow people to book space and pay for space. And this was just to address my issues as a landlord at the time. Because I was losing money with bad debts, not getting paid rent, and keys were going missing, like I said, and the cost of replacing keys, changing locks as well, and giving out those keys again to the right people who need to use the building. And you might have maybe 100 different key holders for a front door, for example. The cost of going to meet those people, actually giving out those keys and identifying the right people to give access to, was troublesome and costly. So I wanted, at the time, I said to the college, could you build me something like, I said, Daft, where I could rent out my spaces so people could choose some drop-down menus like type of property, size of property, location, duration, budget, and so on. At the end of that, they would get options. They could select an office for 2 months in the City of London, make a payment in real time with a bank transfer and our credit card. And if it was a successful transaction, the keys would be generated and sent out to the user's phone and sent out to the door that they wanted to go through in that location. So that was what we set out to do. It took us about 4 years of R&D because it had never been done before, time restricted monetized access to use mobile phones. And I filed a patent in America in 2016, I think it was, and it was just granted just 18 months ago. And we filed other patents in Europe since then, in America, but that was the first big one we got. We got into the market in 2019 around December with a social housing provider in the UK, and that was going well. We had plenty of business in the pipeline, and COVID hit in March 2020, and as you all know, the whole real estate market just collapsed overnight, and so did our market, and all our pipeline of sales. So I met with my team, and I said, you know, there were other things I wanted to do back in the first time that I invented the access control system. What I really wanted to do was, when I spoke to the college, I wanted to connect all the technologies used in buildings like access control, CCTV, alarms, telephone usage, internet connections. I wanted to be able to bill people by the second. And at the time, the college in Tralee said to me it couldn't be done. Technology wasn't there. IoT was in its infancy, wasn't even a word people could relate to or even knew about. So we just concentrated at the time for the first 5 years on the access control. And so I brought up this conversation again with my team, which were different people from where I started. And they said to me, yes, it can be done, because one of them was actually working on a technology to connect industry technologies, protocols. So I said, look, I want to connect all these technologies in the building, I said. And I said, the problem with across portfolios, across different buildings, and across different countries is that the guys supplying CCTV or HVAC or building management systems or IoT sensors, Zigbee or Z-Wave or whatever it is, they're using different protocols in every building in the same country, in the same city, or in different countries. And you could have, I think there's about 20,000 protocols used by all the different technologies in buildings. And so I wanted to build a system that would connect technology that's existing in a building, but also if I wanted to add new technology after, so legacy technology and new technology. And so we set out on our journey about a year and a half ago, and this is a huge undertaking. And the first step was to build what we call a universal translator, or a black box, if you will, connect all the protocols into one universal protocol, one language. And we started out in that journey, and we've gone, I suppose, we're about 20% there in terms of we've connected the most commonly used protocols in buildings in Ireland and the UK. And so what we need to do now is to build a platform. So, you know, in every building, like I said, you have CCTV, you have access control, you have building management systems, you have HVAC, air conditioning, tenant management platforms, IoT sensors, as Ralph and James and Richard were talking about, there are energy management systems as well. And the problem is that they're all siloed information. They don't talk to each other. So in large buildings like Richard would have there on campus, you could have 4 or 5 people monitoring dashboards in a big building. And what we want to do is basically reduce down those dashboards down to 1, and reduce down the amount of people who need to monitor those things down to 1 as well. And then you can manage maybe 10 or 20, 30 buildings from the one place. So we're talking about building a digital twin for the operations of a building, as opposed to a digital twin in the construction. A digital twin for the operations of the building. Like I said, a platform for platforms that you can plug and play legacy technology and new technology in a safe, secure manner. And this is quite a big project. And so we're actually talking to potential partners at the moment in cybersecurity and in energy management, and we're talking to third level institutes as well about the possibility of delivering this operating system, a digital spine, an operating system that we can bring to the market in about 18 months' time. Like it's going to take probably 20 or 30 people's IT people of different disciplines as well to bring all this together. And to reach the ISO 27001, ISO 41000, I think, is for facilities management. So we can bring a product to market that it can be put into a building remotely, or it can be done on premise as well, depending on the needs of the owners of the building. You know, it's great that there's a lot of these technologies existing out there, like energy management technologies, and there's brilliant access control technologies, and there's brilliant tenant management technologies, and brilliant IoT systems out there. But to bring them all together, that's the goal for us, and to be able to offer a trustworthy, autonomous enabled buildings to the real estate industry. And that's where we want to get to provide building owners and operators with a platform that standardizes data from various sensors, devices, systems, and apps. And this invaluable data will not only reduce energy consumption, but also help reduce costs by offering an interoperable technology for all building related information. Like I said, we've made some significant progress in developing the software that's converting the protocols into a common protocol. But now we need to build the software on top of that for the back-end dashboard, the cybersecurity to prevent from hacking, and to build the user interface as well. So, you know, we have the universal translator built. And to accomplish our goal, our ambitious project, we're seeking partners. Like I said, we're talking to people with a cybersecurity firm at the moment. We're talking to an energy technology company, and we're looking to talk to third level institutes like Minute, and UL, and maybe University of Blanchardstown, who have a lot of expertise in cybersecurity. And we're also looking for a large building owner or operator to partner with for testing purposes. I suppose in conclusion, a technology will revolutionize building management by providing a platform for platforms, offering building owners and operators unparalleled control and valuable data. And we are excited about the future and potential impact our solution can have on reducing costs and improving efficiency within the real estate industry. So that's it, Denise, and thanks for your attention, and I welcome any questions you may have.
Thanks so much, Damien. That's brilliant to hear, I suppose, what's coming down the line. And it's also interesting, I suppose, the journey that you've taken to get to this point, and how I suppose it was born out of a need that you identified and that you were experiencing as a business. So it's also really great to hear, I suppose, about the collaboration you have with academia and researchers in that space. So I think we'll definitely be hearing a lot more about digital spine and the fact that you're building that interoperability into it at that early stage. So thanks so much for that, Damien. So we're on to our last speaker, and that is my esteemed colleague Dore. So Dore is an assistant professor for the School of Business in Maynooth University and is also a member of LERO. She is a former research fellow in IVI and a senior research member of the Business Informatics Group. She's team lead in a project investigating the application of enterprise architecture in smart cities funded by Science Foundation Ireland, and has been a principal investigator for an industry fellowship program as well, funded by SFI. She's presented her work at international conferences and has published widely in research journals and conferences across the world. So she's also leading a huge amount of international collaborative research initiatives that we don't have time to go through them all. So please do connect with Dore afterwards as well if you'd like to find out more about the work she's doing. So Dore, over to you.
Thanks very much, Dennis, for the introduction. And yeah, actually the profile is over there. I'm not going to continue with that, just saying that I have many years of experience working in industry with building projects, and I have been doing my education during the PhD for building project and design phase mostly, and also, as you could read over there, I have some funding. I had some funding from SFI Ireland to work on the standards for construction industry. As Rolf was talking about them, I had the chance to work with Archdocs and Rolf on this topic. And just saying that over the last 6-7 years, I've been in contact with the companies and with construction industry, and now I am the cluster lead for the digital construction cluster in IVI at Maynooth University. And at the moment, I'm just going to provide a short update on what we are doing under this cluster. Actually, with the great speaks from our guest speakers for today, we know that there are many challenges in terms of information exchange, and also there are many benefits, for example, to the facility plan management industry and over the operation phase of building projects. When we have access to all this information, actually digital information for buildings, as well as being able to integrate the collected data from the IoT devices and sensors, and also put together with the digital information and come up with some new services and smart services for the buildings, or some services to aware people in terms of just promoting energy saving behavior to our citizens. And on that, we have another mission from our work in the university to be able to communicate the research that we are doing in language which is possible for all public to understand what we are doing and why what we are doing is important to all of us lives. And just saying that we had a published article in as IT Brainstorm, and over that we could hear that we could receive a lot of responses, a lot of interest around the topic from the industry. And yeah, we are just would like to invite you to be in contact with us, to collaborate with us. We are working with different construction companies. As you could see with Murphy Geospatial, we had this project based on their challenges, and we would be happy to work more with more companies which are interested to work with us and to conduct some research around the topic, around the challenges which are of interest to their own business and our company. And our webpage at ivi.ie is available, and under that we have the construction, digital construction page available, and our details are available over there. Please feel free to be in contact with us if you would like to work with us, and if you would like to collaborate with us. And thank you. I'm going to hand it over to you, Dennis. Thank you.
Thank you, Zora, and a nice summation there as well of the work that you're doing there within the cluster. I think it's been a fascinating session so far. It's just, it really emphasizes, I suppose, as well, how broad this area is, and the various different area subsets within that, the complexities in it also. So I would remind anyone, if you have, we have some questions here to get through, but if you still have questions or even comments, please do pop them in the Q&A, and we'll make our way through those questions. So I'm going to pop over to another screen here for a moment to just look at some of the first questions that were coming through. So I'll go to James first off. James, there are some questions in around the process. How would the process incorporate the changes into the building plan, and if there's any research work being done on this?
Yeah, so the process is implemented by early engagement, really. It's about talking to the right people at the start of a project, and in Murphy's case, coming in early on a project to sort of embed that idea of quality on a project. And what was the second part of your question?
It was if there's any research work currently being done in this area.
So no, actually, the research project is kind of concluded at this stage. It was mainly looking at the return on investment, as I'm showing there. But no, it's a large area, it's a new field, and so there's definitely areas that research could be done.
Okay, because I suppose it is leading to that, the as-built plans of how this actually fits in to the as-built plans. And I guess if anyone else has any comments around that as well, unless James, you want to add something further on that.
I guess, yeah, it's that idea of making sure nothing goes wrong, and that has to be implemented, and you know, catching these problems early on is the main thing, really. Yeah.
Excellent. Thanks, James. Sorry, work away.
Yeah, thank you so much, Dennis. It was an interesting question, because James, you were talking about the actually construction phase and the changes which are happening, for example, which is inevitable, and they are there, they are happening. But also I was thinking that the work that you have done in terms of relocating any object at the time of building, that's very important. And later I'm going to invite Ralph to talk about this topic, because this has been the research that we have been working, and it has been of interest to us in terms of just finding the appropriate location for the objects in the building spaces. And then because over the construction phase, we need to create the as-built plans, and it is going to be submitted to the client when the project is done. This is something necessary and mandatory. But also, I think it's very important to just resolve the problem in terms of interoperability, because this is a huge challenge. And I was wondering if you have any plan to see all this initiative across building life cycle, not only the construction phase. That was my type of question. And then I would like to invite Ralph if you would like to add something to this.
Yeah, so I suppose, thanks for the question, Dora. what Merck do is in the construction phase for this example here, but our idea as the role of the construction surveyor is evolving is that you're trying to create that ideal digital twin at the end of the day, that perfect as-built model. And it's just about having, when you, from initiation phase and planning phase, when you get that information and you put it in the right place and it's delivered to the right people, and that is how you build the perfect digital twin at the end of the day for the use phase.
Yeah, I think my comment would be about people's perspective or window. Yeah, everybody has a very narrow window of how they look at this issue. So if you're a designer, like all you're thinking about is getting the design done and moving on to the next design. You know, you don't actually, you're not worried about how somebody's going to build it, and you're not worried about how somebody's going to maintain and operate it. Like that's not in your scope. And the same thing with contractors. Like contractors want to get the job done. They want to get it built, they want to get paid, and they want to get on to the next job. And it's Richie's problem to sort it out afterwards. Like he's left with this issue of having to maintain and operate facilities for the next 20, 30 years and live with all the inherent problems that have been built into the infrastructure. And so, everybody has this narrow window of or perspective. And I think the trick really is to broaden that. And the only way I can see that happening is if clients like DCU, say at the very beginning that we don't want you just to design a building and move on. We want you to design a building that we can build, but also that we can maintain and operate, and that will achieve certain performance in terms of energy use, etc. And we need you to design that with all the systems built into it. So we don't have to come and retrofit all the sensors and things that we need to maintain and control it. And so you've got to be very specific at the beginning and set out this the stall. And I mean, the UK have done great work in this regard in terms of their sort of soft landings initiative, which is basically a methodology of incorporating people with facilities experience into the design process, so that these things are considered throughout design and construction and achieved. Like even what you said in the last sentence there, James, about building this as-built model, that's actually quite a narrow window in itself, because all you're thinking about is at the end of construction, there's this perfect model that represents what was constructed. But buildings are not static, sorry, they change all the time. So it's not about building something at a point in time. It's about how do we set it up that this digital twin is maintained over time, including design, construction, and operation. So that's really the message, I think, is we have to stretch everybody's perspective.
I think that's interesting, Ralph, as well. I suppose, as you describe it right now, it's quite linear, as you said, moving from design phase to the next phase and that. So do you see, you mentioned about kind of bringing people with facilities management into the design stage. So it's really changing the whole life cycle of the project from the get-go, really. But do you think, what do you think?
There needs to be someone at the table. Like you have a fire engineer at the design table to build in fire engineering ideas, and you have an energy consultant at the table in design stage to build in, but you need a facilities person sitting at the table saying to the designers, what you're designing here is not going to be easy to maintain and operate. What you're building in problems that I'm going to have to deal with for the rest of the next 20 years. And somebody needs to say it, because I'm speaking as an architect now. I've never built anything in my life as an architect. I've designed buildings, but I don't have to design, I don't have to build them, and I don't have to maintain them. So I don't have the expertise to say how something has to be maintained and operated, and so you have to have that expertise at the table. It's a mindset change, and clients have to appoint somebody. Somebody's got to be the client, and that's the problem. Is the clients are saying, well, I'll bring the facilities manager in 3 weeks before handover, and that'll sort the problem out. That's too late. All the problems have already been built in to the building at that stage.
Richard, actually, just to you then, I suppose, coming at it from the client perspective as well, do you see resistance to be able to kind of go that approach instead?
No, well, we consider ourselves in DCU to be pretty proactive from that point of view. So within our estates team, we have 3 kind of sub teams, a projects team, an operations team, and an energy team. And the projects team kind of, manage the building of all these new builds or refurbishments. But the operations and energy teams are a core part of a project from conception right through to final completion. So we're sitting at the table right from the conception of a project. So from my point of view, I'm making sure that it's designed to be an NZEB building, low energy efficient design, making sure it's a minimum of an A2 rating, make sure we maximize our renewables. The last few years, making sure that there's no fossil fuel. So any new build project that you see in DCU, there's no gas pipes running to it. It's all fully heat pump, electric buildings, net zero ready. So when the grid is fully 100% green, that building will be 100% green. So Ralph is dead right. If we're not sitting down and the operations and facilities team are not sitting down with the project managers and the design teams, then you're not going to get a building that's easy to maintain and easy to manage. So yeah, that's why it's important to sit down. And it's also very important to get the building model. So the building information modeling is great from the perspective of making sure it's well designed and everything's coordinated. But if you can then move that model into an energy model, like Apache or something like that, then you can dynamically see how the energy requirement is throughout the year in the building. And then if you can take that energy model and then take it into the building management system, then you're able to operate all the energy systems in accordance with the low energy design. So it all is kind of one part of one big circle. So yeah, we do that, and I think a number of universities would do that. I know the energy people in Maynooth, and they would be the same way. But there's probably lots and lots of examples out there where people aren't sitting down at the table with the architects from day one, and it's not a good idea.
Yeah. So you had your hand up. Did you want to come in there?
Yes, actually, I had a question to Richie, because we know that there is a huge problem when we don't have the updated information and digital information when we want to provide such interesting services that you already explained. And we are actually facing that issue and that problem. And I was wondering, what if we could use all these possibilities, as James explained, the new possibility to do model the existing buildings, and also, or for example, integrating the new models with the old, with the information for the old buildings. You know, for the new buildings, for example, we are doing some type of new building modeling, as you mentioned, is going to be asked from the contractor. But yeah, what if we have this extension or refurbishment? How it would be beneficial to us if we could bring in this new knowledge, this new initiative for the refurbishment, for all of these things together to create more services. Any idea about that?
Yeah, well, I think it would be fantastic to do that, but there's just one big issue, and that's cost. Like, I mean, we have 90 buildings in DCU. You know, some of those buildings were designed and built before AutoCAD, so they're drawn in quill and ink. Ralph probably remember the quill and ink days, but that's how buildings were designed. So we have a lot of kind of paper and ink drawings, and they're the only records we have apart from digitized versions of them. For our space management, we digitize all the floor plans, and they're put into kind of like an intelligent drawing system called Insight. And then we're able to manage and allocate and account for space across all of our campuses and all of our buildings. But you know, it would be a massive investment for us to take a lot of the older drawings, paper drawings, but also even some of the older AutoCAD drawings, and bring them into a building information modeling, and then bring all of those into an FM model. That's what we'd like to do, and we are kind of doing it kind of slowly but surely, but it's a resource issue in terms of finance and bodies. You know, we've 90 buildings. We're trying to do the best thing for all our new builds, but for existing buildings, some of them dating back to the 80s and 30s, digitizing something like that is is expensive. So
there's probably technologies now that would make it an easier process, and you actually wouldn't start with the drawings, because the drawings are probably 100 years old and not relevant anymore. So using laser scanning and various other photogrammetry and other technologies that are available, you could probably achieve the same result without.
So we're actually doing that at the moment with I don't know if you are familiar with Smart DCU and Kieran Mahan in Smart DCU. So Kieran has a camera that he's strapped to himself, and he's walking around buildings in the All Hallows campus, and he's digitizing them. And then they're producing floor plans, and they're producing elevations, and they're producing sections. But it's still early days. They're not coming out quite right, but they are coming out pretty good. In fact, there was one image in my slides that actually came from Smart DCU. Probably should have pointed that out earlier on, but on the modeling slide, if you look, there's an image, and that was produced by Kieran just walking around with a camera strapped to him. He had to walk around the building in a certain direction, and all the doors had to be open at the same time. So if one door closed, the camera would not remember what happened, and then it would get confused, and it would all. But so it took us about 3 or 4 attempts, but we digitized the building. So yeah, Ralph, absolutely. The problem is there's pipes sitting in the ceilings, there's pipes in the floor, there's ducts in the floor, there's cables, all of that information that will be on a new AutoCAD drawing. It's very hard to bring that into a kind of a smarter way to digitize that information. I'm sure it's on the way, but that's the challenge.
You don't even know if the AutoCAD drawing is correct, because the plumber that installed the pipes on site probably didn't follow the drawing directly. Kind of said, "Well, I've sort of put it there. I'd go straight across there instead of taking a bend." So this as-built thing that James is talking about, of capturing reality as it's happening. Obviously, that's good for new buildings, but I don't know, James, how do we capture reality for the buried stuff?
Well, that's actually really being done. It's called, like, what I've gone through with digital construction, but there's a department in Murphy's called digital engineering, which literally does that. Like, they 3D scan an old building and then build the model from that information, and then that's how you can digitally retrofit, for lack of a better term, an old building.
How do you find the stuff that's buried? I mean, is there technology, like, I know for underground services you have like radar scanning, but is there something similar for finding the pipes in a ceiling or in a?
Yeah, absolutely. Yeah, for cleaning, it's literally a case of going up there with the scanner. So it's a bit of a crude way of doing it, but yeah, there is. And then for subsurface, you have ground penetrating radar, which can pick up on pipes and lay out that 3D model.
Great, thanks, James. And Damien, I just want to come to you. As I suppose listening to the discussion here and the views, and back to Ralph's point as well around that shift in mindset. Do you think that would help? I suppose the development further or rollout of the digital spine area that you were working on, and what you're doing there, because maybe at the moment is it quite late in the stage, in that whole stage that you're coming to the table? So just kind of wondering what your thoughts are on this kind of shift in mindset that's required here, and how it can impact what you're doing.
Yeah, ideally that would be how all buildings are developed, when you've all the stakeholders in together from the start. But as Ralph said, it doesn't happen that way. It should happen that way, but it doesn't. But I suppose from our point of view, we're developing a technology that isn't aimed primarily at new buildings. It can be used in new buildings, but it's aimed at existing real estate and that are using all technology. So whether you're using old technology, legacy systems, or you want to use technologies, we've taken a plug and play approach to bring in a universal plug and play platform. So, you know, of course, there's limitations to that as well. You can only go back so far. Like building management systems wouldn't want to be any older than maybe 2015 or 16. Yeah, in an ideal world, you could from day one, you sit down with the architects, engineers, and all the stakeholders, facility management people, and build it from there. But obviously, you know, we want to be adapting our technology to as many buildings as possible. So that's why we're looking to plug into the old tech and the new tech and make it vendor agnostic, so that the manager of the facility isn't tied into any one supplier, which can be very expensive and it usually comes with long contracts. And we want to give the owner or the facility management operator the freedom to choose who they want to use, and you know, if they're unhappy with a particular vendor, they can change.
Absolutely. I suppose it is even being able to try and create partnerships earlier at that business level to try and suppose counter the issue of not bringing all stakeholders to the table early. I guess that's one approach. It's easy to say to do that. Of course, do that in practice is very, very different.
I think when there is data standards and management standards brought in, like you know, it'll come to a stage where the people who provide the money, like green finance and insurance and banks, they'll start dictating what your building has to have in order for them to insure it, maybe for lower risks premiums, or finance to extend the building or renovate the building or sell the building. And that, of course, then will affect then who's going to buy your building, or who's going to want to have it in a portfolio. So also other factors like that may force the hand of developers to think 20 years ahead or 30 years ahead, and bring the stakeholders in now, as Ralph was saying and Richard was saying, you know, and that, so it might take external factors like that, which are coming actually very quick with the advent of ESG and green energy and the whole net zero platform, you know, they might force that quicker than people actually realize.
I think that's definitely an interesting view on it, because as you say, the regulations, the standards, all of that are changing and evolving all the time. And if they become the driver of this, then it could be very interesting. Sorry, Ralph, did you want to come in there?
Yeah, well, and I thought what might be applicable when you look at all these standards and your responsibility to comply with these standards, then the granularity becomes important, because I mean, you can manage energy on a house at your bill. You could just look at your electricity bill, your gas bill, but that's not enough. Like you need to dig in and find out which which piece of equipment in your house is causing the problem. Yeah, so you got to dig in, but humans don't like granularity. It's because it's too much detail, but technology loves granularity. So you can, if you are monitoring every single piece of equipment in your building at that sort of granular level, you can make much more educated decisions, and you can have much more accurate predictions of your compliance with these different regulations. But if you're only looking at your overall electricity bill or your gas bill, like you have very little control. So I think that's the role that technology has. Computers love tons of data. Yeah, they can work all day, all night. They don't take weekends off. They don't have holidays. They'll just crunch data over and over again. And yeah, we just got to figure out how to capture. Well, I think capturing the data is not a problem. It's just how to use it, how to bring it into something meaningful. And I suppose to Richard, I'd probably say that, you know, obviously in your future buildings, you can instruct the design teams and construction teams to build in sensors into the system straight away, so you don't have to go retrofit them. But in your current stock, you have this problem that you have to go and retrofit all these IoT devices on everything in order to get to that granular level of measurement and control.
Yeah, I think what we do is, for us, we manage energy by identifying our significant energy users. So
yeah,
start at what's significant, and then we work our way down until we're at a point where we think we can manage as best we, as best we can. So it's important to kind of, look at your significant energy users and then go monitoring from there. Yeah.
And sometimes the significant users are human being rather than a piece of equipment.
Absolutely.
So, I heard an example once of it was a meat processing plant, but they saw a spike in hot water production every Thursday, and they couldn't figure out why, because they do the same process every day. Yeah, so why would Thursdays be any different? But it turns out that the security guard that was on duty on a Thursday forgot to close some valve, which was part of the routine that they had to go through. So for the whole night, the hot water was just flowing into the waste.
Yeah.
So it was a human error rather than, but only because they were monitoring.
Well, that's it. That just shows
Yeah.
the importance, and that's what our monitoring and targeting system is able to see. When something occurs that shouldn't be occurring, and we can then identify and see where that is, eliminate it, and we get back. So yeah, part of kind of what we do is constantly monitoring, setting targets, monitoring again, setting targets, and making sure that we can baseline as much information as possible. In fact, COVID was great for that, because as we were locking down buildings, we were seeing the minimum energy use. We were only ever used to kind of Saturdays or Sundays to see what a building was doing. But when nobody was actually in the building, we were able to monitor and see our energy consumption. And then we were able to go around and see what pieces of kit were on that maybe could be knocked off. So we were able to baseline energy in all our buildings. And that's why, since we've come back to normal after COVID, our energy consumption is still staying at a low level. Whereas a lot of people out there are going, we're using way more energy since COVID. But for us, we're actually still improving our energy performance. And that's because we used that COVID downtime to really understand our buildings. And in the future, you don't need lockdowns. It's the data and the intelligence that should be able to give you all that information. But it is a challenge when you have 90 existing buildings trying to incorporate that technology. It's in terms of financing and resourcing it is a challenge.
I hate to be the one to stop this discussion because it's extremely interesting, and I want to thank all the speakers, but we are at time, and I think it has definitely identified opportunities to collaborate and talk further on this with everyone. And if there's anyone who has any questions or wants to reach out to the panelists afterwards, please do get in touch. So just finally, I just want to mention a upcoming event. I think you should be able to see it there now. So you can also, first of all, sign up to our newsletter to stay in touch, or contact us on info@ivi.ie. We also are really looking forward to the IVI Summit, which is taking place on the 22nd of June in Maynooth University. It's based around co-creating the digital world beyond 2027. So please do check that out and register if you'd like to come along and listen to some interesting discussions, and also some breakout sessions and interesting workshops in the afternoon. So I just want to thank everybody for their time today, for tuning in, for their questions, and again to the speakers for their really insightful presentation and views. So thank you very much, everybody.